Good morning. My name is Pilar Martinez from Technical University of Madrid, and I'm going to present this study called Tracking Greenhouse Gases Emissions for Biomethane Production from Pig Manure and Comparison with Conventional Fuels. This is the structure of the study. Firstly, I'm going to do an introduction of the sector and the biomethane biogas. Second, I'm going to explain the objective of the study. Then, I'm going to explain the methodology employed for the life cycle assessment. Finally, the results and conclusions. In the graph, we can see the evolution of global amount of pigs in last decades, in last 5 decades concretely. We can see that from 1960, the amount of pigs have been duplicated, and more than duplicated, from 400 to 1,000 amount of pigs in 2021. It could be attributed to two main reasons. Firstly, in the improvement of socioeconomic conditions that improve the quality of the feed used for humans and increase the meat consumption. Here in the maps, we can see the evolution of global human development index from 1990 to 2015, and we can see that most countries has improved the human development. And the second reason is the increase of global population, where if there are more people, there are more meat consumption due to there are more people. This could produce two main problems. Firstly, is the climate change. The agriculture is the sector with the highest anthropogenic methane emissions in 2022. In 2022, and is the second sector that has most global methane emissions, independent of the origin of the emissions. This is a big problem that we need to have solutions to that emissions produced during the agriculture and in livestock farms. The second problem is the waste management, because the animals produce waste, and it's necessary to treat this waste have not to not have problems in the soil or in the atmosphere. This is a bit old reference, I know. Here we can see that in 2011 in Europe, most manure has no had no treatment, and the little few that go to a treatment, the most common treatment of manure was anaerobic digestion. Under this context is appeared the project of Life Smart Mobility, that is a live project from European Commission that is based on a construction of a real pilot plant in Salquillo de Boñices, Soria, Spain, in the middle of Spain. This project has the aim to produce biomethane in a farm from manure for pig manure. And the big advantage of this project is that it's possible to produce biomethane with a little amount of biogas. That is a bit novidious, because most projects of biogas are concentrate the pig manure from different farms, and is a deslocalized production of biomethane. And this is a localized production of biomethane, and this is a deslocalized production of biomethane, where each farm could produce their own fuel. Firstly, the manure is stored in ponds, mainly due to security condition and ensure that manure is safe for biogas and humans. Some of that manure is directly used as fertilizer, and the other part is goes to a anaerobic digester, where biogas is produced through anaerobic digestion. This digester could be use a heater to maintain the temperature constant in the digester. After that, there is a part of the solid fraction that is called digestate and is used directly as fertilizer, and the biogas is goes to a absorption column. Then there is mixture with microalgae. The microalgae are grown in the raceway, that is a pond with a little shadow that with sunlight the microalgae grow, and they absorb the carbon dioxide from the biogas. If we remove carbon dioxide for biogas, we produce biomethane with which is rich in methane. After that, the biogas biomethane produced goes to a filter to remove humidity and sulfuric acid, and then is suitable to use as fuel in vehicles. In the project, we only use the biomethane for conventional vehicles and not for agriculture, like tractors, but it's possible to use there. Also, the microalgae could be used as fertilizers. Here are the objectives of the projects. We have four objectives. Firstly, is to quantify the energy produced in this plant and the potential of replication. Second, to analyze the greenhouse gas emission producing during the project, the biomethane production in the whole chain. To compare the biomethane greenhouse emissions with other fuels, and finally to study the potential solution to reduce the greenhouse emissions produced in this project, because we have measures that could improve the emissions produced. To do that, we are going to use the methodology of life cycle assessment. This methodology is used for calculate the impacts produced of a product or an industry or whatever. The scope that we have is cradle to grave, including all stages of biomethane. Here we have a graph that we can see that there are included the states of manure storage, anaerobic digestion, digestive treatment, biogas upgrading, and biomethane compression. The method that we are going to use to calculate the climate change impact is the one proposed by European Commission, that is environmental footprint version 3.1. This method has more categories, but we are focusing on climate change. And the functional unit that we are going to use in the study are the energy contained of biomethane, that is megajoules. It's necessary to study the manure properties to determine the fugitive emissions of manure during storage. Here we have the properties of manure used in that reference, that the manure of the real pilot plant in Soria, and also the condition of fertilization. This is the results in the plant. As I said in the introduction section, the biodigester use a heater to maintain the temperature constant. So we have two different, and the heater use the own biogas of the digester to maintain this temperature. So we have a total production of biogas and net production of biogas if we rest the amount consumed by the heater. The total amount of biogas produced is 85,000 meter cubics per year, and we rest the amount consumed by the heater, we have 55 megajoules, 55,000 meter cubics per year. This represents 3,040 megawatts hour per year. This amount of energy is the same for biogas and biomethane because the amount of energy is contained in the methane. So if we remove the carbon dioxide, we don't reduce the energy contained. And the biomethane produced in this project was around 40,000 meter cubics per year. If we calculate for a potential replication the amount per peak, we obtain that one peak can have the potential of produce 13.3 meter cubics per year of biomethane, that which represents 0.114 megawatts hour per year. Here we see the greenhouse emissions produced in this project per stage. We can see that most methane and nitrous oxide emissions are produced during the manure storage. In contrast, the most emissions of CO2 are produced during the usage phase. We can see that the carbon dioxide emissions are in grams, and methane emissions and nitrous oxide emissions are in milligrams, that they are 3 orders of magnitude lower. Important to say that these emissions contains fossil and biogenic emissions. If we use the environmental footprint, we can remove the biogenic emissions, obtaining the kilograms of CO2 equivalent that is shown in the slide, that they are 21.9 grams of CO2 equivalent per megajoule. It could said that the fuel is sustainable according to the European regulation 2015-1513, where they say that they have to, if a fuel is renewable, they have to prove that they have a reduction, has a reduction of 60% from the reference fuel, that is 94 grams per megajoule. Here we can see the comparison of kilograms of CO2 equivalent produced per megajoule of biomethane of life smart mobility and other fuels like natural gas, gasoline, diesel, kerosene. The reference fuel of the normal of the European regulation is 0.94. That 0.09, sorry, 94. That this could be like here, like one moment, here, like here. And here we can see that biomethane has less than 5 times emissions that the conventional fossil fuels that they are using in vehicles or in agriculture vehicles. Here, I'm going to present the potential solution to reduce even more the greenhouse emissions produced by biomethane. Here, reduce this number. The first one is to cover the pond during storage. This could reduce a lot the methane emissions and the CO2. The problem is that the nitrous oxide emissions will be increased, but they are much lower than the other ones. The second option is to change the heater to produce more biogas, because if we have the same emissions and we produce more energy, we are going to reduce the impact per megajoule. Option to reduce, to change the heater is to use other residual heat from other industrial process, or use renewable heaters, for example, solar or geothermal heaters. The third option is to improve digestate treatment. That actually the digestating life smart agromobility pilot plant is used directly as fertilizer, but it could be used for produce more biogas in a second biodigester, or use it for other to produce ammonia. So if we use the digestate, we can reduce the whole impact because we have more products. And finally, uh, a measure could be have a centralized grading. That's true that it reduces more the cost than the greenhouse emissions, but um, it could help to produce. The reason of that is to produce biogas in each farm, concentrate the biogas of more farms, of several farms, and use this biogas to produce biomethane. It could reduce the cost and localize the emissions of CO2 and digestate in one point. That could be easier to have measures to reduce that. Here we can see three conclusions of this study. Firstly, is that biomethane produces most CO2 emissions during the usage phase of the fall, while the most emissions and nitrous oxide, of methane and nitrous oxides are produced during the manure storage. This is important because if we localize where the emissions are produced, it's more possible to do measures to reduce that, like covering the pond could reduce the emissions of methane. The second conclusion is that biomethane production in life smart agromobility is enough to use as a fuel for a vehicle. The minimum concentration of biomethane of methane in a vehicle fuel is 85%, and this project proved that a microalgae upgrading produce enough quality for vehicles, and this fuel is sustainable according to the European regulation. And finally, we have studied and conclude that biomethane, maybe it's a bit obvious, but we have found that biomethane has less emissions of greenhouse emissions than conventional fuels. 75, 76% then less than natural gas, 78% less than gasoline and kerosene, and 77% less than diesel. Thanks for your attention.